After we have got some of the basic concepts of limits, we move on to a more involved process, that is derivative. This particular topic is of prime importance in physics, chemistry, and every field of science and mathematics, and it forms the basis of calculus. So I would like you to get this concept very clear in your head. So let's first of all see what this concept involves. So suppose let we have a real valued function, as you might recall from your functions tutorial. A point A is a point in its domain of definition. Then the derivative of f at A is defined as limit h tends to 0 f of A plus h minus fa upon h. This is the particular expression for calculating the derivative, and if this particular limit exists, that is, if this exists, then we say that the derivative exists. If this limit doesn't have a defined value, then we'll say that limit derivative doesn't exist. Derivative doesn't exist. Okay, so this is also called the the derivative through first principle. We'll you will see more principles and how to calculate the derivative faster in later classes. So after doing this, I also want to tell you that the derivative of x at a is denoted by f dash a, or it can be there can be another notation, that is del of d of d by dx of the function fx at x equals to a. This is another way of saying this the same thing, and this is a general notation which we'll use here. This particular expression is often misleading. It says that we have multiplied d by dx to this particular thing, but it's not. It's just like an operator, as we have plus and minus in our earlier classes. So this is an operator and not the simple multiplication, and this d and this d won't cancel out. Often people do this mistake in your first term, so don't ever do this mistake. This d and d won't ever cancel out. So this is the particular expression, and these are the notations. So now we have a similar but a subtle, more involved definition in for the algebra of the derivatives, which says that if we have two functions f and g, and the limit as x tends to a and limit as x tends. So let f and g be two functions, is that both f dash x and g dash x exist at say x equals to a. Then we'll have the following particular rule, which says that limit f dash x plus g dash x equals to f dash x plus g dash x, or so we have the derivative of fx plus gx is equal to the derivative the sum of the derivative individually, that is f dash x plus g dash x individually. Or for the subtraction case, we'll have same thing, that f x minus gx the whole dash is equal to f dash x minus g dash x. To prove this, let's work this out through the first principle. So let's write down the definition of the expression written in the LHS. So to write down the definition, we'll see that the definition of this particular thing will be limit as h tends to 0 fx plus h, let's write down, is equal to limit h tends to 0 f of x plus h minus plus g of x plus h minus fx plus gx upon h. Now taking the terms of fx on one side and gx on the other side, we'll have the expression as this. So this particular expression is, as you note from the first principle, gives f dash x, and the second expression gives g dash x. Similarly, you can prove for the minus sign also. Now this is the second property and is known as the product rule. This is the product rule of the derivatives. This and the next rule is quite important to solve the various derivatives very fast. So I would like you to just work out its proof, um, and I'll give a general hint to how to solve it. So let's write down the derivative of this particular function by the first principle. So we have limit h tends to 0 f of x plus h into g of x plus h minus fx minus fx gx upon h. This is the first principle. Now to convert it into this particular form, what we need is the addition and subtraction of the term f x gx plus h and f of x gx plus h. Now after adding these terms, just see these two terms and these two terms, and you will be able to derive the expression. It's easy to derive the expression now. Just let me go. Let me just move you through this once. So if you double these terms and take common as g of x plus h, so then you will have g of x plus h into f of x plus h plus okay, don't couple these two terms, couple this and the last term. Okay, let's just go back. Couple these terms and these terms. So if you couple these two terms, you'll be left with g of x plus h. So let's write down. I don't think it will take much time. So let's couple these two terms. We have f of x plus h minus fx upon h here. Now this may seem familiar to you through the first principle, only if we don't have this g of x plus h. So now using the algebra of limits, that if the limit of the individual parts exists, then we can uh, separate these two limits as limit of g of x plus h differently and limit of this particular expression differently. So we'll have limit of h as limit of g x plus h as h tends to 0 as gx. So this is the first term into this particular expression when h tending to 0. So this is equal to h tends to uh, this is equal to f dash x. So here this gives us the first term, and if you couple these two terms, you'll simply get the second term. Now this is called the questioned term. This is called the questioned rule. It may seem a bit tedious at first go, but I assure you after you've practiced, this will seem a very simple exercise to you. So to calculate this particular thing, let's erase everything. So let's mark out, this is Q rule, this is P rule. So to prove Q rule, again we'll use the same fact that we'll write the derivative of this particular expression by using the first principle. So let's write down limit as h tends to 0 f of x plus h upon g of x plus h minus fx upon gx upon h. Now taking LCM, we'll have limit h tends to 0 fx plus h into gx minus f of x into g of x plus h g of x upon h into gx plus h into gx. Now we'll separate this particular term and the remaining terms, as the limit of this particular term exists and this individual term will also exist, as you will see later on. So the limit of this particular expression will come out to be 1 upon g square x, that is gx into gx, and we are left with only the term, this particular term. So we'll have f of x plus h into gx minus fx minus fx into gx plus h. Now to solve this particular expression, we'll again we require to do a manipulation. So in the numerator, we'll add and subtract f of x. So we'll subtract f of x this and add this. So now to get this expression, we'll simply club this and this term and club this and this term. So as you can see, if after we club this term, we'll have gx as common, and in bracket we'll have fx plus h minus fx upon h. So this thing, so we'll have limit, just separate out these two terms, we'll have limit gx into f of x plus h minus fx upon h, and the second expression would be minus limit h tends to 0 fx into gx plus h minus gx upon h. Since this is a constant, we can take it out, and this particular expression remaining will be equals to f dash x. So we'll have gx into f dash x minus fx into g dash x. So this gives us the question rule. These two rules are of prime importance in solving the derivatives faster, and just keep on insisting. I keep on insisting all the time that you have to remember the first principle to get a good grasp at the derivative first. So there are very simple methods which are just which you will be easier to find the derivative with, but do practice the first derivative, first principle of derivative, because it gives the basic feel of what the limits are and what the derivative are. There's a geometrical concept to this. At this stage, I don't think it's comfortable for me and you to understand that. Okay, thank you. I hope this video tutorial was helpful in getting some idea or the basic concept of limits and derivatives. But I recommend to do a lot more practice than just the questions which are discussed in this particular video tutorial to get a grasp of what actually we are doing in the limiting process.